For case study 5, I'm going to be talking about vigabatrin and GABA and the effects on epilepsy. So first, GABA is gamma antibutyric acid. It acts as an inhibitor neurotransmitter in the central nervous system. It's opposed by the excitatory neurotransmitter glutamate, and it causes hyperpolarization of the postsynaptic neuron to generate an inhibitory postsynaptic potential. It reduces the activity of the neurons in which it binds, and it inhibits nerve transmission in the brain. So it works as a neurotransmitter, and in immature neurons, the GABA is an excitatory and depolarizes the cell due to elevated intracellular chloride ion concentration. As neurons develop, the amount of the active sodium-potassium chloride transporter decreases, and the amount of active chloride extruding potassium chloride transporter increases. So the KCC2 effluxes chloride ions out of the interneuron. And intercellular chloride decreases until GABA switches from being excitatory to inhibitory. So it primarily works as an inhibitory neurotransmitter. Increasing GABA at the neuronal synapses inhibits the generation of the action potential of a neuron. It's primarily an inhibitory neurotransmitter, which means it decreases a neuron's action potential. When the action potential drops below a threshold potential, the neuron cannot generate action potentials and cannot excite neurons nearby. So when there is little or no GABA, the nerve cells will fire too easily and often, and this then results in anxiety, addiction, and headaches when there's low GABA activity. So neurons are firing too much, and that results into symptoms. So when there's damage to an inhibitory interneuron, it can lead to epileptic activity, which leads to vigabatrin. So vigabatrin creates an anti-seizure effect that's due to being an irreversible inhibitor of GABA. It increases the level of GABA in the central nervous system, and it's the only drug that is specific to a patient's physiology based on the GABA receptors. And it's structurally identical to the GABA, but it has an additional vinyl group, as you can see in the image. To continue, it's designed to be an enzyme-activated, irreversible, selective suicide inhibitor of GABA. It works as an inhibitor of GABA catabolism by a GABA T, which increases GABA in the synaptic cleft and enhances the GABAergic transmission. And it also reduces glutamate and glutamine cycling between erythrocytes and neurons. And then here is the structure of vigabatrin. And finally, my references used.